Hello, good morning. My name is Taufik Alif Kurniawan. Today we will discuss about the measurements and instruments part 2. In this chapter, we will learn about the operating principle of devices that we will use in measurements, especially in electrical and electronics engineering.
Today we will discuss about the still in chapter 1 measurements and instruments part 2. Okay, first we will discuss about the electronics voltmeter for DC. So as you know that the voltmeter is the tools that be used to measure the voltage, and the signal in the electrical we have two parts, the AC signal and also DC signal. In this slide we will study about the electronics voltmeter to measure the DC voltage. Here's the block diagram of the electronic voltmeter DC. It consists of three parts. The first one is potential divider, and then the DC amplifier, and then this is the meter. And potential divider network is the function is to reduce the input in case it is high to make it suitable to give as input to the amplifier. So as you can see in this circuit diagram, the first one, this one is potential divider. We have three kind of resistor here to divide the voltage. This is 9 mega ohm, 900 kilo ohm, and 100 kilo ohm. So after we divide the voltage and we measure the input voltage here, this is the input, the DC. Before going to the amplifier here, we have to divide to reduce the input voltage, and then amplifier circuits to enhance the signal so that the sensitivity and resolution of measurements improve. And then we have the rectifier and filter circuits in case the meter for deflection is a DC meter. So you can see here the DC meter, and then this is the meter or rectifier and filter circuits. Okay, this is the electronic voltmeter for DC. And then the meter, the third part, has a two device. The first one is direct couple amplifier, and then second is copper type of DC amplifier. And you can see from the book this kind of the direct couple amplifier and copper type DC amplifier. And I mean that when we have to use the first one and when we have to use the second one. And then the second device, we will talk about the electronic voltmeter for AC. So we can see this one, the block diagram for electronic AC voltmeter is little bit difference with the DC voltmeter because we have the rectifier here, and then for the first one we have the potential divider. And then however, designing a DC amplifier is more difficult and expensive because the input signal must be from to 0 hertz. The frequency must be 0 hertz. So the input AC signal is first is amplified, and then rectifications, and then filterings, and we can see the DC meter is used for deflections. So we have another block diagram for electronic AC meter. So we have like this one. We have the input here and then divide in potential divider. We have the DC amplifier here, and then third DC amplifier, it is changed the DC amplifier before the rectifier from the first block diagram, and the second is the DC amplifier before the rectifier in the second diagram. Okay. And IC voltmeter is we can divide into three categories. The first one is average reading voltmeter, and then the second is peak responding voltmeter, and then the third is true RMS responding voltmeter. The difference between the average and peak responding voltmeter is in the filter. So the difference is in the filter circuit, and you can see the discussion of three kind of this AC voltmeter in the book in page 49. And you can see we have three kind of circuit: peak reading voltmeter, and then peak to peak detector for the function in AC voltmeter. Okay, so the next we will talk about the DC meter with the amplifier. You can see this is the circuit diagram of DC voltmeter circuit with the FET input. So we use the FET amplifier here. So this amplifier circuit has the high input impedance. So therefore, the current draw from the circuit under test will be less. The circuit has unity gain amplifier here. This is the unity gain amplifier with the high input resistance. And then we have a source follower here, drive and emitter follower. Okay, so the input impedance of the meter is about 10 mega ohm, and then the power required is 0.5 deflections is 0.025 microwatts. And the power required for a meter without amplifier for the similar 0.5 volt deflection will be 25 microwatts. So the sensitivity in this circuit is about the 10 times. So we have another version of DC meter with the amplifier. I mean that we can divide amplifier voltage and the current meter in the similar devices. So in the second kind of the DC meter with amplifier, we have two. In the beginning of the circuit, we have a switch. Either we will use the amplifier voltage, or we will use the current meter. You can find the discussion in the textbook. And then the next, we will talk about the AC voltmeter for rectifier. You can see from this figure that we have the DC mode operation based AC voltage AC voltmeter circuits. And electronic AC voltmeter are similar to the DC meters, except that the AC is rectified before it is amplified to the DC meter circuit. You can see here the diode here. The diode is the function is to rectify. So this is the basic differences between the AC voltmeter and the DC voltmeter. In the DC voltmeter, the first one, we have the divider, and we have the divider here. So this is the basics difference between two kind AC and DC is in the AC we have to use the diode for rectifier. Okay, and then so this one, the first circuit, this is the DC the rectifier. The series connected diode providing half wave rectification. So I mean this one D1 for an average reading meter. And then the 4 diodes, it a bridge circuit for a full wave rectification and application to an average reading meter. And then we can also use the sun connected diode used in peak reading voltmeter. As I can mention before, we have a 3 kind of the voltmeter, average average voltmeter, peak reading voltmeter, and another versions. So in this case, we can use the single diode like A for the average reading meter, and also the for diodes. And for the peak reading voltmeter, we can use the sun connected diode as in figure C. And after we learn about the AC voltmeter for rectifier, we see the electronics multimeter. So the multimeter consists of the balance bridge DC amplifier and an indication meter, and then the second we have the N input attenuator or range switch to limit the magnitude of the input voltage to the desired value. And then the third, we have rectifier sections to convert an AC input to a proportional DC value. And then in the electronic multimeter, we have the internal battery and additional circuits to measure the resistance. And we have the function switch to select various measurement function of the instrument. And you can see that multimeter can measure the voltmeter and ampermeter in using a similar devices. We have the difference between the voltmeter and then the ampermeter. Voltmeter just for measuring the voltage, and then the ampermeter just for measure the ampere. And we can use the multimeter in case to measure both of the signal in the circuits. And then this is the AC current measurements. After we talking about the voltmeter, this one is AC meter measurement, so it will be used to measure the AC. And the first one, we can use the differential voltmeter, and it is one of the most accurate means of measuring an unknown voltage. Here the unknown voltage is compared, so this is the reference, is compared to the known voltage, and it is also is called a potentiometric voltmeter, since the principle of operations is similar to the potentiometer. And then the second version of AC current measurement is AC differential voltmeter. For AC differential voltmeter, sometimes if we want to measure the high voltage, and high voltage reference supply can be used here. And then the AC differential voltmeter is a modification of DC differential voltmeter. We can see this is the AC differential voltmeter. It consists of this is the AC input here, and then we have the attenuator, and then we have the AC to DC converter, and then we have the potentiometer here, similar to the differential voltmeter. And then the unknown voltage we compare to reference supply here. So this is the AC differential voltmeter. And then the alternating current instrument AC, we have the different type of AC meter instruments. There are 5 kind of the meter movement. For the DC, we can use electrodynamometer, and then we can use iron fan also for DC and AC, and we can use electrostatic is also for DC and AC. And then we can use the thermocouple for DC and AC, and we can use the principle of D'Arsonval for the DC and AC, but for AC we need rectifiers here. Okay, so this is a different type of AC instruments. And then the next we will talk about the thermocouple meter. Okay, so this is the thermocouple instrument. We have a source here, and then if the input is the current here, and then we have a heater here, and this is the thermocouple. We have the D'Arsonval meter. then this is we can use this for the AC and DC. For AC, it can be used over wide frequency range, even is above 50 megahertz, and there is no other deflecting instrument type that can measure current up to that frequency. So it means that this is the if we need to measure the AC signal in wide frequency until even about above 50 megahertz, we can use this kind of device, thermocouple meter. And then how to select the analog voltmeter? So sometimes we need to choose whatever we want to use the analog voltmeter or digital voltmeter. Is the basic is if the analog voltmeter, so it depends on the deflecting analog sign, and then for digital we just see the measurement value in the screen, so it will be convenient. Sometimes if we only have analog voltmeter, so there is some principle how to select the analog voltmeter. The first one is the input impedance of the kind of analog voltmeter. The input impedance is about 10 mega ohm or in that range. And then what is the voltage range? It's about the 1, 3, 10 sequence or 1.5, 5 to 15 sequence millivolts, 10 volts or 10 second of volts. And then what is the decibel for wide range of voltage or narrow wide range of voltage? And then what is sensitivity? Is about 1 millivolt or 100 microvolts. And then what is the bandwidth? It's about 10 megahertz to 10 hertz to 10 megahertz. So it depends on this criteria. And then also the battery operations. You can select what's the best analog voltmeter that fit your measurements. And please study from the textbook another material until the end of the chapter 1. It's about the digital voltmeter, and then RAM type of DVM, Starcast RAM type of DVM, dual slope integrating type of DVM and SAC, continuous balance type DVMAC, automatic polarity indicating for the DVM, auto range for DVM, picoampere meter, low current amperemeter application, and high resistance measurements. So this kind of the subchapter you can find in the textbook in chapter 1. Okay.
After we discuss the measurement and instrumentation in chapter 1, we will study about the waveform generators in next week. So please study the remaining subchapter in measurement instruments part 1 as explained in the PPT slide. And do the exercise and homework. We meet again next week in the new chapter. Good morning.